Hi everybody. So what we want to do here is we want to take a second and we're getting towards the end of the semester. We're starting to review for our final exam in statistics. So our last class in Math 013, what we're going to be doing is taking a look at the Excel spreadsheets, and we're just going to practice putting values into there and getting used to when do we use which Excel tab. So you've got a final exam version of the Excel spreadsheets. This is the one that has all of the tabs. So when you take a look, you're going to want to make this full screen whenever you're working on it. And you can see the tabs are down here. And these are all the ones we've used throughout the semester. So I'm going to take a second. I'm going to go through each one of these tabs and talk about when you're going to use them. So one variable statistics. Again, I've cleared these out for you, but when you type these values in, one variable statistics, these are going to give us mean, median, mode, standard deviation of a population or sample. It's up to you to determine which one that is, sample size, and it gives us our 5-number summary. So we will use the one variable statistics tab when we are working with basic descriptive statistics, 5-number summaries, and then you use these to help build your box and whisker plot. The next tab we're going to take a look at is the discrete tab. Again, I want to encourage you, most of the time we would use just the discrete probability distribution. We haven't seen very many where there's just frequency data given. So again, this is where you're going to have these, you're going to have some values. You might have to set up this might be necessary when you do expected value as well, but you have whole discrete numbers over here and on the left-hand side for the x's, and then in the probability of x tab, those are usually percentages that you will represent as a decimal. And then what you need from here is this will give you the mean and standard deviation, also variance, but we haven't really been asked to find that one. So mostly just putting these values in to find the mean and standard deviation. Again, sometimes you need to do that with an expected value as well. The next tab is the binomial probability tab. Remember, this is when we have a fixed number of trials and we are looking for a specific number of successes. So something like if I were to try to get, let's say I flip a coin 12 times and try to count the number of heads I get. So this, if I flip a coin, the probability that I get a tails is 0.5. Let's say I flip a coin 10 times and I want to find the probability of getting 3 tails. So this is how we enter in there. We would enter our probability, the number of trials, and the number of successes, and then it will spit this probability down here for us. Next one, we've used this for quite a bit. The normal distribution tab. This is the normal CDF. So this is if we are finding a left-tailed or right-tailed distribution. Remember, if you look at a normal distribution, sometimes it's shaded to the left or shaded to the right. We would use the top left or right tab, and you would enter in the mean, the standard deviation, and then whatever that X limit value is, and then you would need to determine was it shaded to the left or was it shaded to the right. Similarly, we had times where we had space in between the normal distribution shaded, so something like a lower and an upper limit, and it's shaded in the middle. This is where you would enter the lower value, the upper value, and then whatever the given mean and standard deviation is. The last thing we did was sometimes you were given a percentage shaded, and it asked you what that z-score value or what that value was. That was the cutoff between, say, the top 5% and the bottom 95%. So here you would enter your mean, your standard deviation, and whatever that area value is, and you need to determine was it below, above, middle, outside. Usually it was below or above. We also used the left or right or in between when we used a normal to approximate a binomial situation. So if you remember those times where we did something like, instead of flipping a coin just 10 times, if we flipped it 200 times, this is when we would find that NPQ, mean standard deviation, and then you did that continuity correction. So we use this normal distribution tab quite a bit. Next one is confidence intervals for means. So we have two different situations, one with mean confidence intervals with population standard deviation sigma known. We don't use this one very often because we rarely know the value of sigma. So more often than not, we're going to be using mean confidence intervals with population standard deviation sigma unknown. Again, more often than not, when you're doing a confidence interval for a mean, you're going to be using this right side over here. You'd enter your sample mean, confidence level, sample standard deviation, and sample size, and it will spit the confidence interval here. So I'm just going to make up some numbers. And then let's say we have a sample size of 200, and then it spits your confidence level out here. Sometimes you're given data. If you're given data and you need to find your mean and standard deviation, you would enter those values into this table below. And then that's going to give you your mean and standard deviation and sample size, and you will transpose those up here, and then you would get your confidence interval out. Very similar thing happening here with proportions. Proportions, remember, are percentages. So whenever you're asked to find a confidence interval for a proportion, you need a value of p hat. Remember, this is the percent of success. So let's say we had a 40% success, and our sample size was 135, and we were going to do a 0.9 confidence level. So there would be our confidence level right here. Sometimes you don't have p hat given to you. I just like to use my calculator to divide x by n. That can give you your p hat value, but if you don't, you can always use this one over here. So over here, confidence intervals mean. This is for proportions. We're going to see something similar with hypothesis testing. So the first one is hypothesis testing for proportion. Remember, you're going to set up your null and alternative hypothesis. This one always stays equals, but here you're going to choose from greater than, less than, or less than, greater than, or not equal to, depending on the null and alternative you set up. Then you're going to put some values that were given to you in the problem in terms of a p hat, like the sample data you got, your sample size, and your significance level. And then that is going to give you your p-value right here, and it's going to give the critical values. The most important thing you need right here is your p-value. Similarly, if you don't have p-hat given to you, I just made up the number 0.3 here. You might have an x and n. You can enter those in right here, and it will give you your p-hat value as well. Similarly with means, sigma unknown. We never know the standard deviation for these ones. We didn't work on the ones where we do know sigma, so you're going to set up the null and hypothesis just like what you did with proportions. Please make sure you're changing this one to match up with what you have on your paper. Then you have a sample mean, sample standard deviation. So I'm going to make some numbers up. Sample size, let's say it was 25, and then significance level. These are all given to you in a problem. That's what we're going to be working on in stats today. And then at that point, what you're going to do is you're going to take this p-value. Again, if you don't have these values given to you, you may need to enter them into here to get your sample mean, sample standard deviation. And again, you will transpose those. One quick thing, please make sure when you enter these values in, if I have one final value hanging out there, you need to make sure you press enter, and that will compute it for you. Finally, linear regression. This is where you're going to enter those pairs of values. Sorry, let me fix these real quick. So you're going to enter the values that are given to you. Remember, you use these when you work with bivariate data. Bivariate data is data that comes in pairs. All right, so once you get those values in there, this is your linear regression line right here. This is your correlation coefficient, R. Again, you use that to tell whether there is a correlation or not. Coefficient of determination we didn't use a lot except for a couple homework problems. They give you the mean of the x values, and they also give you the mean of the y values. Remember, you're either going to be using this regression line or this regression line depending on whether there's correlation or not. That's based on this R value and the numbers on the back of the formula sheet. So we're going to be putting numbers into these and just practicing getting the data in there and getting the data extracted from the spreadsheet once you have stuff entered. And hopefully that will help when it comes time to take stats, as you're not fumbling around these spreadsheets trying to figure out which one to go to.